Hello and welcome to my tutorial on mass, weight and the centre of gravity. So we're going to talk about mass, weight and density first. So the mass of a body makes it resistant to changes in volume and motion, and the mass of an object is the amount of matter in it, and it's measured in kilograms. The greater an object's mass, the greater its resistance to the change in velocity, or it's called inertia. The mass of an object doesn't change if the strength of the gravitational field changes. Weight is a force and it's measured in newtons. Weight is the force experienced by a mass due to a gravitational field, and the weight varies according to the size of the gravitational field acting on it. And weight is mg, or mass times the gravitational field strength, which is 9.81 on Earth, and it's what we use in exams, unless they tell you otherwise. And density is the relationship between mass and volume, and its units are grams per centimeter cubed. So one gram per centimeter cubed is 1,000 kilograms per meter cubed. So if we have an example, 150 kilograms times 9.81 can equal 1,470 newtons. So now we move on to the next part. What is centre of gravity? It's where all the mass is in one place. So this is part 2. Centre of gravity is a single point where you can consider its whole weight to act through. The object will always bounce around the point, although in some cases the centre of gravity is falling outside the object. And you do it in an experiment. So if you hang an object freely from the corner, if it's a regular, if it's not a circle, perfect sphere, a square, or a rectangle, then you can hang it from a point, and then draw in a vertical line from the point of suspension, and then hang the object from another point, draw another vertical line down, and then find the centre of gravity where the two lines cross. No data is collected for this particular experiment. It's just to find where the centre of gravity lies. For a regular object, you can use lines of symmetry. The centre of gravity of any regular shape is at its centre. So if we look at a square now, its centre of gravity will be right in the middle. And if we look at how high the centre of gravity is, it tells us how stable the object is. So a stable object it has a low centre of gravity and a wide base area. It's stable when it's like that. And when it's at critical angle, the higher the centre of gravity and the smaller the base area, the less stable it will be. And if it's completely unstable, it will topple over if a vertical line is drawn downwards from the centre of gravity and it falls outside the base area. It will always fall over. Now we'll look at some questions. So what is density? And a cylinder of aluminium radius 4 centimeters in height, 6 centimeters, has a mass of 820 grams. Calculate its density. If you want to use it in kilograms, it's 0.820 kilograms. But be wary, I've left the answer in grams. So when you get to it, just divide it by 1,000. Use the information from part A to calculate the mass of the cube of aluminium of side 5 centimeters. So looking at the diagram, A is 4, the radius, and B is 6 centimeters, the height. So I'll give you 5 seconds, and we can look through the answers. Okay, so the density of an object is the measure of the compactness of a substance, and it relates to how much space a mass can take up, how much volume. It's the relationship between mass and volume. That's it. That's your definition of density. And now looking at the calculations, we need to use P equals mv, but first we need to find the volume. So just using P equals mv gives you a mark in this particular question. And then using pi r squared times h gives us the volume, which is 301.6 centimeters cubed. And then 820 over 301.6 is 2.72 grams per centimeters cubed. And for B, the volume is 5 cubed, which is 125 centimeters cubed. The mass can then be rearranged to 340 grams. That's it. Thank you for watching.